This is Unit 2, Fractions. So let's talk about fractions a little bit. Pen to work, there it goes. Fraction, we have a line going across like this, something on top, something on the bottom. Typically numbers. Like this right here. Now, the top part is called the numerator, and the bottom part is called the denominator. I refer to this as the top, I refer to this as the bottom. Sometimes I use denominator and numerator and so forth. Now, a way you can remember those names, people have done in the past, is denominator, D for down, and N, numerator, N for not down. So this is as good as it gets, I think. Now, when we're talking about fractions, not that I can actually split this up. Let's say we had something, we divided it in thirds. That's probably as good as I'm going to get. So this is our whole down here. And then we're looking at two of those, the whole. So 2/3, if I were to shade it, I'd shade one of these, and then I'd shade another one. So that'd represent 2/3. Well, let's take a look at the first problem here. This introduces something called an equivalent fraction. We're starting with 1/3. And we want to write it with a new denominator. That's what an equivalent fraction refers to. Well, you have to look at your old denominator, the 3, and you ask yourself, what did you multiply it by to get the new one? Well, you multiplied it by 4. So you have to multiply the top part by 4. Well, 1 times 4 is 4, so it'll be 4/12. So 1/3 and 4/12 are equivalent. You know, example that. Here's something that I split up. Those are 4 equal parts. You have to use your imagination. Well, if I shade 2 of these, like that, that would be 2/4. Now, if I take that same picture, and I split it just in 2s, and I shade this right here, you see this is more or less, if I draw this a little bit better, is the same, and this would be 2. There's 2 total, and then one of those is shaded. So 2/4 and 1/2 are equivalent fractions. So let's take a look at 1/5, and we want to write it with a new fraction, with a new denominator. Now, again, you have to look at your old one and ask yourself, what did you multiply by to get the new denominator? Well, we multiplied this by 6. We have to multiply the top part by 6. And 1 times 6 is 6, so we got 6/30. And that would be our answer. Let's see, we got 4/7. And got 21 down here, wondering what the top part is. Well, again, you look at the old denominator, you ask what did you multiply by to get the new one. Well, I multiplied that by 3, so I have to multiply the top part by 3. Well, 4 times 3 is 12, so we'd have 12/21. Now, these next ones talk about simplifying the fraction. Now, I'm going to show you 2 different ways to simplify this. I show you 2 different ways because the easiest way some people can't do. Okay, 4/12. To simplify this fraction, another word for that is reduce. What you do is you look for the largest number that divides into the top and bottom. Like the largest number divided into these is 4. So I do 4 divided by 4 over 12 divided by 4. Well, 4 divided by 4 is 1. 12 divided by 4 is 3. So 1/3 would be our answer. Okay, now some people can't see what's the largest number that goes into that. An alternative way of doing this is to do the prime factorization of each of those numbers. Like 4 would be 2 times 2, if you remember this from Unit 1. 12 would be 2 times 6. The 2's prime, so circle it, and 6 is 2 times 3. So we can take our fraction and do the prime factorization at the top and prime factorization at the bottom. The top would be 2 times 2, and the bottom would be 2 times 2 times 3. Now anything they have the same, you can cancel out. See how this one has a 2 and this one has a 2? Those can cross out. This one has a 2 and this one has a 2, so those can cross out. Now everything's disappeared up on top, and everything's gone in a fraction. You're always left with 1. And then there's a 3 down below. So that's another way to simplify it. It really doesn't matter how you simplify it. This first way is easier if you can actually see what number divides into both of those. Let's take a look at this one. Got 12 over 24. And simplify the fraction again as the instructions. Well, the top and bottom are both divisible by 12. So we take 12 divided by 12 and 24 divided by 12. Well, 12 divided by 12 is 1. 24 divided by 12 is 2. So our answer would be 1/2. Now you can do the prime factorization if you wanted to. I'll show one more of those and I won't show it anymore. I'll do it this first way. 12 over 24. Well, the 12 is 2 times 2 times 3. And 24 is 2 times 2, well, 3 2's, and then a 3. Well, this has a 2 and this has a 2, so those cancel. 2 and 2, those cancel. 3 and 3, so those cancel. So we're left with nothing up on top, which is 1, and then 2 down below, which will give us 1/2. Now let's say you're trying to use this first method, and you didn't see that they were both divisible by 12. You saw they were divisible by 2, for example. That's fine. Whatever you see, go ahead and dive in and start doing it. So if I do 12 divided by 2 and 24 divided by 2, a lot of times you don't write that step out. 12 divided by 2 is 6. 24 divided by 2 is 12. Now at this point, you see, oh, well, they're still divisible by something. So you can continue on going through the steps. So you don't necessarily have to get it on the first try. It'll become obvious. Sometimes I don't see it. I think I see they're both divisible by this number, and I dive right in with that, and then it's like, oh, there's another number they're both divisible by. Let me save that. Name of this unit is probably fractions, if I had to guess. Fractions. And let's see, healthcare, math, fractions, page 01. Okay, let's look at another one. $30 over 50. Now I'm showing this one because this is a real easy one, and I want to point out the trick for it. Now the top and bottom are both divisible by 10. So I got 30 divided by 10 and 50 divided by 10. Well, 30 divided by 10 is 3, and 50 divided by 10 is 5. So my answer would be 3/5. When I said they're real easy, if you have zeros at the very end and you're reducing a fraction, you just cross off the zeros. So it doesn't matter how many there are, it'll work that way. So didn't have to think any of that. So the 0 here, cross those off, you got 3/5 as your answer. Let's take a look at this one. We got 12 18ths. Top and bottom are both divisible by 6. So 12 divided by 6 and 18 divided by 6. Well, 12 divided by 6 is 2. 18 divided by 6 is 3. So our answer would be 2/3. This one is 5 and 3/6. And this is a mixed number. We have a number in front of it. Now that's equivalent to 5 plus 3/6. But with mixed number format, we drop the plus and just put them right next to each other like that. Now that does not mean 5 times that. That means 5 plus 3/6. Well, in simplifying this, you just look at the fraction part. 3 and 6 are both divisible by 3, so we got 3 divided by 3 over 6 divided by 3. 3 divided by 3 is 1, 6 divided by 3 is 2. So our answer is 5/2. Showing a lot of these because a lot of times people struggle with fractions. So the areas where they struggle with, I try to put a little bit more focus. Well, same thing. We're going to simplify the 20 over 24, and they're both divisible by at least 4. So I got 20 divided by 4 over 24 divided by 4. 20 divided by 4 is 5. 24 divided by 4 is 6. So our answer is 8 and 5/6. In this one we got 2, 33 over 44. Same instructions, simplify it. Well, the 33 and 44 are both divisible by 11. So 33 divided by 11 and 44 divided by 11. 33 divided by 11 is 3. 44 divided by 11 is 4. Okay. Now, there's another way of trying to decide some of this. You got 20 and 24. And to me, it's easier to look at it, but or do the prime factorization. But to decide how these are both divisible by 4. Well, if I look at 20 and 24, for example. The 20 is 2 times 2 times 5. And 24 is 2 times 2 times 2 times 3. Now, to figure out our greatest common factor, you look at what they have in common. You see these have 2 2's, and these have 2 2's. So the greatest that they have in common is 4. So that's how we can divide everything by 4. This one is a 5, but these don't. Here's an extra 2, but this doesn't have the extra 2 up here. Here's a 3, but this one doesn't have a 3. So that's how it would give us that. Now, let me scroll up here a little bit, see if we got another one that was interesting. 12 and 18. We divide both by 6. Let's look at 12 and 18. Well, 12 is 2 times 2 times 3. 18 is 2 times 3 times 3. We're looking at what they have in common. These have a 2 in common, and these have a 3 in common. So 2 times 3 is 6. Now, if you go this route to figure out what to divide both of them by, personally, I think it's just as easy to do the prime factorization. I don't think I have one of those here. To do the prime factorization of the fraction and then just cross out what they have in common. So, if you can't see it. Let's go to the next problem. This is, I think, a reducing one in a word problem format. It says, write the fractional part that represents, that should be that, represents the relationship of the parts to the whole. Then reduce all of your answers to the lowest form. It says 40 out of 120 patients at clinic are men. What is the fractional part of men to total patients? Well, there's 120 total. So you put the 120 down below. And out of those 120, 40 of them are men. So I put 40 up on top. Now remember what I said earlier about the zeros at the end. These both have zeros at the end, so I can just cross those off. And we got 4 12s. Well, the if I think of what number divides in both of those, that'd be 4. So 4 divided by 4, and 12 divided by 4. Well, 4 divided by 4 is 1. 12 divided by 4 is 3. So our answer would be 1/3. Now this next problem introduces an improper fraction. It says write the following improper fraction in mixed number form. Improper fraction means your number on top is larger. So that's an improper fraction. Number on top is larger. Well, let's see how to change this to a mixed number. Our first step. Use old style division. So I'm going to take 10 and divide by 3. Now 3 goes into 10 3 times. 3 times 3 is 9, and then 1. Now we don't add any zeros on here. That's where we get into decimals. This is old style division. So our answer is 3 with the remainder of 1. So to put this in mixed number format, we move numbers as our second step. So our answer is 3 1/3. Now, where does everything come from? This number right here is what goes out in front. Our remainder goes right up there. And what we're dividing by, right there, goes down here. So that's how everything ties together. Let's look at another one of those. We've got 25 sevens. 13. Oops. Change it back to black. .25 sevens. Again, we use old style division. I'm going to take 25 divided by 7. That gives us 3. 3 times 7 is 21. And subtract those, and I get 4. So again, this is going to become 3 4/7. This number here goes out in front. Our remainder goes up on top, and whatever numbers here goes down below. That's just our original denominator, stays the denominator. So that would be your answer, 3 4/7. One more. We got 33/5. Again, I'll use old style division. 5 goes into 33 6 times. 6 times 5 is 30. And then subtract that and we get 3. So our answer then will be 6 3/5. Again, whatever number's on top here goes out in front. Our remainder goes up on top there. And our denominator just stays the same. Like that. Grab a drink real quick. Actually, I'm ready for a new page. Now this one talks about adding fractions. So let's look at that. 1/3 plus 1/3. And this is adding fractions with a common denominator, with like denominators. Remember, denominator is a number that's downstairs. So first step, they already have the same denominator, so we're going to add the top parts and put it into a single fraction. The denominator stays the same. So like on this one, we'll add together the top parts, so we got 1 plus 1 over 3. Now 1 plus 1 is 2, so that'd give us 2 over 3. Now our second step is to simplify the fraction, reduce the fraction. Now remember, you can only simplify it or reduce it if the number on top and number on the bottom are both divisible by something. In this particular problem, it won't reduce, won't simplify. So 2/3 is our answer. Let's take a look at this one. We got 2/10 plus 3/10. Now they have the same denominator, so we'll add together the top parts. So we got 2 plus 3 over 10, and 2 plus 3 gives us 5, so we got 5/10. Now step 2, simplify, reduce the fraction. I notice the top and bottom are both divisible by 5, so 5 divided by 5, and 10 divided by 5. 5 divided by 5 is 1, 10 divided by 5 is 2, so our answer is 1/2. Let's take a look at this one. We got 1/4 plus 3/4. Now look at the instructions here. Add the following fractions, reduce as necessary. It actually wouldn't need to say reduce. That's implied. Anywhere in mathematics where you can simplify, reduce your fraction, you should. Well, here the denominators are the same, so I'll add together the top parts. So we got 1 plus 3 and put over 4. Well, 1 plus 3 is 4, so we got 4 over 4, and actually the fraction disappears because 4 divided by 4 is 1, and that'd be our answer. Let's see, 5/12 plus 3/12. Again, the denominators are the same, so we'll add the top. So we got 5 plus 3, and we'll put over 12. 5 plus 3 is 8. So we got 8 over 12, and top and bottom both divisible by 4. 8 divided by 4, and 12 divided by 4. 8 divided by 4 is 2, 12 divided by 4 is 3, so our answer is 2/3. Let's look at one with a mixed number. So we got 3 and 1/6. Plus 8 and 1/6. Now what you do is if you got a mixed number, you add together the whole parts, the numbers that are out in front. 3 plus 8 gives us 11. And then you add the fractions together. 1/6 plus 1/6. Again, they have the same denominator, so I'll add the top parts, put them over the single denominator. 1 plus 1 is 2, so that gives us 2/6. And 2/6 reduces. Top and bottom are both divisible by 2. So 11 and 2 divided by 2 is 1, and 6 divided by 2 is 3. So our answer would be 11 and 1/3. And let's take a look at this one. We got 7 1/5 plus 4/5. And again, we'll add together the whole parts that are out in front. There is no whole part out in front of the 4/5, so the 7 just is by itself. Now we'll add the fractions. 1/5 plus 4/5. I'll add top parts. 1 plus 4 over 5, which gives us 5 over 5. Now remember what this represents. This represents 7 plus the fraction. So 7 plus 5 over 5. So 5 over 5 is 1, and 7 plus 1 gives us 8. Now you don't have to show all the steps I'm showing here. I just want to really illustrate why does this become 8. Most people just go straight from this step down to there. I say most people. That's once they're comfortable with fractions. Okay. Here we got 1/15 plus 4/15 plus 5/15. Now it doesn't matter how many fractions you have. If they all have the same denominator, you can add together the top parts and put them into a single fraction. So I got 1 plus 4 plus 5 over 15. 1 plus 4 is 5, plus another 5 is 10. So that gives us 10/15. Top and bottom are both divisible by 5. So we got 10 divided by 5 over 15 divided by 5. Well, 10 divided by 5 is 2, and 15 divided by 5 is 3. So our answer would be 2/3. And let me save that, and we'll start a new page. And there's one more. So let's take a look at this one. We got 5 and 2/20 plus 7 and 3/20 plus 2 and 10/20. Now normally in math, actually let me get a drink first. Normally in mathematics, we want to simplify fractions whenever we run across them. But occasionally, our goal is to get the same denominator. Notice how these all have the same denominator, 20. I wouldn't want to simplify these fractions, reduce them, because they're already in perfect form. Well, let's add the numbers that are out in front. 5 plus 2 is 7, plus another 7 is 14. And these all have the same denominator, so I add together the top parts. So we got 2 plus 3 plus 10, and then put it over 20. Well, 2 plus 3 is 5, plus another 10 is 15. So we got 15/20. Top and bottom are both divisible by 5. So 15 divided by 5 and 20 divided by 5. Well, 15 divided by 5 is 3. 20 divided by 5 is 4. So our answer would be 14 and 3/4. Now those were the fairly simple ones. Now we're going to start getting into what do you do if you don't have the same denominator. Those are the ones a little bit harder. So let's take a look at 23. We got 1/4 and 1/6. And it says find the common denominator in the following pair of numbers. Well, there's different ways of getting a common denominator. We're going to take a look at finding the least common denominator. So finding the least common denominator. Now that's the LCD. What we do first is write the prime factorization of each denominator. So write the prime factorization of each denominator. Well, we got 4 and 6. Now 4 is 2 times 2, and 6 is 2 times 3. Okay. Our LCD is the product of each prime the greatest number of times it appears on a single line. Now this one's just asking us to find a common denominator. But let's start with this. Least common denominator. Greatest number of times it appears on a single line. That's each prime. I'll start with my first prime, 2. There's 2 2's on this line. There's 1 2 on this line. Now we're looking for the greatest number of times it appears on a single line. We're not counting how many there are. So the greatest number of 2's on a single line is 2 of them. Now we'll go to our 3. We're looking for the greatest number of 3's appear on a single line. There's none here, there's 1 here. Greatest number of 3's on a single line is 1. So 2 times 2 is 4, times 3 is 12. So our common denominator is going to be equal to 12. Now they're not asking us to rewrite these fractions with it, they're just asking us to find the common denominator. Now a very sloppy way to get the common denominator, and I'd recommend this way because it works all the time, but is to multiply 4 times 6, and that'll give you 24. Sometimes they become big. The least one is 12, not 24. Sometimes 24 works, sometimes it won't. Let's take a look at this one. We got 5 over 36, and we got 1/8. Same instructions. Find the common denominator. So find the LCD. Well, step 1. We want the prime factorization of each number. 36 is 2 times 2 times 3 times 3. And 8 is 2 times 2 times 2. Now remember with your primes, the only thing you can put over there are 2, 3, 5, 7, 11. I'll put a couple more just in case. I don't think there's anything that goes up that high though. Usually it's those first 5 primes. So if you have some other number on the right hand side here besides those, yes, not the prime factorization. Then we'll go to each prime. I'll start with the 2. We're looking for the greatest number of 2's on any single line. We're not counting how many there are. We're looking for the greatest number on any single line. There's 2 of them here. There's 3 of them here. So the greatest number of 2's on any single line is 3. Now we'll go to the 3. We're looking for the greatest number of 3's on any single line. There's 2 here, none here. So the greatest number of 3's is 2. So we got 2, 4, 8 times 9 gives us 72. So 72 would be our least common denominator. Let's see, this one we got 7 over 24 and 1 over 50. And we want to find the least common denominator. So we'll do the prime factorization of each one. 24 is 3 2's and 1 3. 50 is 2 times 5 times 5. Our least common denominator, we look at each prime, start with a 2. We're looking for the greatest number of 2's on a single line. Well, there's 3 here, there's 1 here. So the greatest number of 2's on a single line is 3 of them. Then I go to my 3. There's 1 here, none here. So the greatest number of 3's on a single line is 1. Then I go to my 5's. There's none here, there's 2 5's here. So the greatest number of 5's on a single line is 2 of them. 2, 4, 8. 5 times 5 is 25, times 3 gives us 75. 0, 4, 600, I believe. 56, yeah, 600. So 600 would be our least common denominator. Well, now we're ready to add fractions together that don't have the same denominator. And do I have room here? Yeah, I have room. So let's take a look at this one. We got 1/3 plus 1/6. And this is adding fractions with different denominators. Well, step 1. Figure out the LCD, least common denominator, and rewrite each fraction. So rewrite each fraction with that denominator. So figure out the LCD and rewrite each fraction with that denominator. Now let me do it over here on the side. So we got our 3 and 6. Well, 3 is prime, so we can't do anything there. 6 is 2 times 3. Our LCD. We start with our first prime, 2. We're looking for the greatest number of 2's on any single line. There's none here, there's 1 here. So 2, or one of them, would be our greatest number of 2's. Then look at the 3. We're looking for the greatest number of 3's on any single line. And we're talking about what follows the equals. There's 1 here, there's 1 here. So the greatest number of 3's on any single line is 1. So our least common denominator would be 6. So we're going to rewrite each fraction with that new denominator. Now you look at your old denominator. My first fraction here is 3. And you ask yourself, what did I multiply that by to get my new denominator? Well, I multiplied 3 by 2. So I have to multiply the top part by 2. Basically, whatever you multiply by the bottom, you have to multiply by the top. Now in our second fraction, this already had a 6, so I didn't change it at all. So that just remains as is. Well, 1 times 2 is 2, so we got 2 6 plus 1 6. Now we're going to add together the top parts. This is what we've been doing already, adding fractions with the same denominator. So that gives us 3 6. And then simplify or reduce the fraction. And I don't got much room left here, but both those are divisible by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So 1/2 would be our answer. And there. So that's how you add fractions with different denominators. Let's take a look at some more examples. As soon as I save this. Okay, so we got 5 12ths plus 1 16th. Well, our first step. Figure out the LCD and rewrite each of these with a new denominator. Well, if I do 12 and 16, 12 is 2 times 2 times 3, and 16 is 4 2's. So our LCD, we're looking for the greatest number of 2's on any single line. There's 2 of them here, there's 4 of them here. So the greatest number of 2's is 4 of them. Then I'll go to my next prime, which is 3. And I'm looking for the greatest number of 3's on any single line. There's 1 of them here, none of them here. So the greatest number of 3's would be 1. So we have 2, 4, 8 times 2 gives me 16 times 3 gives us 48. So we're going to rewrite each fraction with that new denominator. Now you have to look at your old denominator and you ask what did you multiply by it to get the new one. On my first fraction I had 12, so I multiplied it by 4 to get my new one. So I have to multiply the top part by 4. Whatever you multiply by the bottom, you have to multiply by the top. Now 16, I multiplied that by 3 to get the new one. So I have to multiply the top part by 3. So that gives us 20 over 48 plus 3 over 48. Second step. They have the same denominator now, so add together the top parts. 20 plus 3 is 23 over 48. Now, I can't simplify that any. 23, I believe, is prime. So we don't do step 3 on this one. There's nothing to simplify. Let's take a look at this one. 7 over 10 plus 3 over 25. Okay, figure out our LCD. So we got 10 and 25. 10 is 2 times 5, and 25 is 5 times 5. Again, we start with our first prime, which is 2. We're looking for the greatest number of 2's on any single line. There's 1 here, none here, so greatest number of 2's is 1. Then we go to the next prime, 5. We're looking for the greatest number of 5's on any single line. There's 1 here, there's 2 here. So the greatest number of 5's on any single line is 2. 5 times 5 is 25, times 2 is 50. So we're going to rewrite each fraction with our new denominator. Now you look at our first fraction, the 7/10. You look at the denominator, 10, and you ask, what did I multiply it by to get the new denominator? Well, multiplied it by 5. So you have to multiply the top part by 5. On my second fraction here, I multiplied the bottom part by 2, so I have to multiply the top part by 2. So that gives us 35 over 50 plus 6 over 50. Well, now that they have the same denominators, you add together the top parts. 35 plus 6 gives us 41. And yet again, this did not simplify. 41, I believe, is prime, so it doesn't break down any. Yeah, let's take a look at this one. One over 16 plus 1 over 36. Well, we have to figure out what our LCD is. So I look at 16, 36. 16 is 4 2's. 36 is 2 times 2 times 3 times 3. 4 times 9. Yeah, okay. So then our LCD. Start with the 2's. We're looking for the greatest number of 2's on a single line. There's 4 here, there's 2 here. So the greatest number of 4's on a single line is 4 of them. Then I go to my 3's. There's no 3's here, there's 2 3's here. So the greatest number of 3's on a single line is 2 of them. 2, 4, 8, 16 times 9 gives us 144. Now sometimes it's not so easy to see what did you multiply by 16 to get the 144. Well, if you got a basic calculator, what you can do, and I know this isn't a basic one right here, but it'll do. If you take 144 and you divide it by 16, like that, you get 9. That tells you we multiplied the bottom part by 9 to get that common denominator. So we have to multiply the top part by 9. So we take 1 times 9. Now here we multiplied this by 4, so we have to multiply the top part by 4. So that gives us 9 over 144 plus 4 over 144. Well, now that they have the same denominator, I can add together the top parts. 9 plus 4 is 13 over 144. And 13 is prime, so this does not simplify yet again. Well, let's take a look at this one. It has 3 fractions. So we got 1/5 plus 1/3 plus 1/4. Same instructions for finding the least common denominator. That hasn't changed. We do the prime factorization of each one of these. 5 is boring, it's prime. 3 is boring, it's prime. And 4 is 2 times 2. So our least common denominator, we start with the first prime, which is 2. We're looking for the greatest number of 2's on a single line. There's none here, 2 here. So the greatest number of 2's on a single line is 2 of them. Then I go to my next prime, 3. I'm looking for the greatest number of 3's on a single line. There's none here, 1 here, 1, or none there. So 1 would be how many we have. And then the 5's. There's 1 here, none here, none here. So greatest number of 5's on a single line is 1 of them. That's 2 times 2 is 4. Times 5 is 20. Times 3 is 60. So we're going to rewrite each one of these denominators with a new denominator. And again, You have to think, what did you multiply by the old denominator to get the new one? Well, 5 times 12 will give you 60, so we multiply the top part by 12. This one we multiply the bottom part by 20, so we have to multiply the top part by 20. Here we multiply the bottom part by 15, so you have to multiply the top part by 15. Whatever you multiply by the bottom, you have to multiply by the top. So that gives us 12 over 60 plus 20 over 60 plus 15 over 60. Add together the top parts. That gives us 35, 45, 47 over 60. 47, I believe, is prime, so it doesn't break down E. It's definitely not divisible by 2 or 3, which is what the bottom part is, and 5. Actually, I guess I'm ready for a new page. So let's take a look at this one. It has mixed numbers. You got 7 3/10 plus 2 1/4. Well, first thing we need to do is to get a common denominator. So if I look at the LCD of 10 and 4, prime factorization of 10 is 2 times 5, and 4 is 2 times 2. So again, we're start with our first prime, which is 2, and I'm looking for the greatest number of 2's in any single line. There's 1 here, 2 here, so it'd be 2. Then I go to 5. I'm looking for the greatest number of 5's in any single line. There's 1 here and none here, so 1. 2 times 2 is 4, times 5 is 20. So we're going to rewrite each fraction with that new denominator. Now the number out in front doesn't change, just a fraction. Well, we look at our first fraction here, 3/10. The old denominator is 10. We multiplied it by 2 to get the new denominator, so we have to multiply the top part by 2. So 3 times 2. On our second fraction, we multiply the bottom part by 5, so we have to multiply the top part by 5. So that gives us 7 6/20 plus 2 5/20. Well, now that they have the same denominator, we add the numbers that are out in front. 7 plus 2 is 9. And then add these together. 6 plus 5 gives us 11/20. We still don't have to do step 3 because 11/20 doesn't simplify. That'd be our answer. Let's take a look at this one. 2 2/3 plus 5 5/8 plus 4 5/6. Add the following. Okay. Well, first thing we have to do is get all these with the same denominator. So we're going to find our least common denominator of 3, 8, and 6. Our denominators. Let's do the prime factorization of each one of those. 3 is prime, so that one's done. 8 is 2 times 2 times 2, and 6 is 2 times 3. Well, we'll start with the first prime, 2, and I'm looking for the greatest number of 2's in any single line. There's none here, there's 3 here, there's 1 here. So the greatest number of 2's in any single line is 3 of them. And then I go to my 3. I'm looking for the greatest number of 3's in any single line. There's 1 here, none here, 1 here. So the greatest number of 3's in any single line is 1. So we got 2, 4, 8 times 3 is 24. And we're going to rewrite each of the fractions with that new denominator. Now our first fraction here, we had 3 as a denominator. We multiplied it by 8, so we have to multiply the top part by 8. So 2 times 8. Our second fraction, we had 8. We multiplied it by 3 to get our new denominator, so we have to multiply the top part by 3. So 5 times 3. And our third one, we multiplied the bottom part by 4, so we have to multiply the top part by 4. So this gives us 2 16/24 plus 5 and 15 24ths plus 4 and 20 24ths. Now this one's going to introduce something new, and we'll see it in the next step. Actually, it's step 3. Well, we're going to add together the numbers out in front. 2 plus 5 is 7, plus 4 is 11. And add together the fractions. So we got 16 plus 15 is 31, plus 20 is 51. Now this is an improper fraction form. And so step 3, remember this is the same as 11 plus 51 over 24. And to change improper fraction to a mixed number, I'm going to do old style division. 24 goes into 51 2 times. 2 times 24 is 48. 51 minus 48 is 3. So then this becomes 11 plus, and this would be, remember the number that goes up in front goes out, or number on top goes out in front. The remainder is what goes right here, and then 24 goes here. Let me draw lines connecting those. Okay, so 2's out in front. The remainder is what goes up here. And our denominator basically stays the same, but whatever number's right there goes down here. Well, 11 plus 2 gives us 13. So we got 13 and 3 24ths. And actually, now that I've done that, I see 3 and 24 both divisible by 3. Sometimes I don't see them right away. It's not until I get it simplified that I can actually see that. So 3 I can divide by 3, and 24 I can divide by 3. 3 divided by 3 is 1, 24 divided by 3 is 8. So that'd be our answer. Which meant I could have simplified to 51 over 24, but I didn't see it. Like I say, some of this stuff just jumps out at you once you've worked it. It's the neat part about fractions. Worst thing you can do is just sit still. If you actually divide by something you see, then you can get it simpler. Let's take a look at one more of those. I'm not sure if this one actually has one that carries, but we'll see. Yeah, it does, because I see 7/3 there. Okay, so we got 33. And I think I have room. So 1 and 3/10 plus 4 and 5/12 plus 7 and 7/3. Well, let's find our least common denominator. We got 10, 12, and 3. 3 is prime, so we don't need to do anything with that. 10 is 2 times 5. 12 is 2 times 2 times 3. So our least common denominator, start with our first prime, 2. We're looking for the greatest number of 2's on any single line. There's 1 here, 2 here, none here. So greatest number of 2's on any single line is 2. Then I go to my next prime, 3. I'm looking for the greatest number of 3's on any single line. 1 here, none here. So greatest number of 3's is 1. Then I go to the 5. 1 here, none here, none here. So greatest number of 5's on any single line is 1. So that gives us 2 times 2 is 4. Times 3 is 12. Times 5 is 60. So we're going to rewrite each one of those with that new denominator, 60. Now look at my first fraction. It had a 10. I multiplied it by 6 to get the new denominator, so I multiply the top part by 6. So we got 3 times 6. Second fraction here, I multiplied the bottom part by 5 to get the new denominator, so I multiply the top part by 5. So we got 5 times 5. And our last fraction, we multiplied the bottom part by 20, so we have to multiply the top part by 20. So this gives us 1 and 18 sixtieths plus 4 and 25 sixtieths plus 7 and 140 sixtieths. Well, now that they all have the same denominators, I can add together the fractions. First, the numbers out in front. 7 plus 4 is 11, plus 1 is 12. And 18, 25, and 140 when I add them together. 8, 13, 1, 2, 4, 8, 183. Now we have to simplify that because that's an improper fraction. Actually, I can simplify it. They're both divisible by 3 at least. So this becomes 12. 183 divided by 3 gives us 61, and this divided by 3 gives us 20. That makes it a little bit simpler. So I divided the top part by 3 and the bottom part by 3. Well, let's change that over now. Because that's the same as 12 plus 61 over 20. And that's an improper fraction. So I can divide 61 by 20. That gives us 3. That's 61. So this becomes 12 plus 3 and 1/20. Again, number on top here is number out in front. Number is a remainder is number on top here. And then the denominator stays the same. Well, 12 plus 3 is 15. So our answer is 15 and 1/20. Let me save that. There's other purposes for common denominators, and this next one demonstrates it. And then we'll take a look at subtraction. Subtraction is about the same as addition, so nothing real exciting there. Okay, so we got 1/3. We got 4/5, and 4/9, and 2/15. And it says order the following fractions from largest to smallest. Well, we can get a common denominator. So let's find the least common denominator of 3, 5, 9, and 15. Well, I'll do the prime factorization of each one. 3 is prime, 5 is prime. 9 is 3 times 3. 15 is 3 times 5. So we'll start with our first prime. It's weird, I don't have any 2's. Okay, start with 3. I have 1 3 here, none here, 2 here, 1 here. So the greatest number of 3's on any single line is 2 of them. Then I go to my next prime, 5. None here, 1 here, none here, 1 here. So the greatest number of 5's on any single line is 1. 3 times 3 is 9, times 5 is 45. And we're going to rewrite each one of these with that new denominator. On our first fraction here, we multiplied the bottom part by, what did we multiply by? 15. So we had to multiply the top part by 15. So I got 1 times 15. Here we multiplied the bottom part by 9, so we had to multiply the top part by 9. Here we multiplied the bottom part by 5, so we have to multiply the top part by 5. And here we multiplied the bottom part by 3, so we have to multiply the top part by 3. So that gives us 15 over 45, 36 over 45, 20 over 45, and 6 over 45. Now again, keep in mind this one right here matches up with this one. This one matches up with this one. This one matches up with this one. And this one matches up with this one. Now, they want them from largest to smallest. Well, if they all have the same denominator, the largest number on top is our largest one. So 36 over 45. Then our next one would be 20 over 45. Then 15 over 45. And then 6 over 45. Now, 36 was our blue. 15 is our red. 20 is our black, and this is our green. There we go. So if I come up here, our blue one was 4/5. So 4/5 is the largest one. 20 over 45 is our black one, which is the 4/9. So 4/9 is the next one. 15 over 45 is the next one, which is our red, which is 1/3. And then a green one, the 6 over 45 is a 2/15. So those are the fractions range from largest to smallest. Let me grab a drink here. Now let's take a look at the subtraction. We got 4/5 minus 1/5. Now these first ones are pretty basic. It's not until we get to borrowing that it actually changes. Subtracting fractions. This is the same as adding, but you subtract the top parts instead of adding them. So, nothing real exciting there. Well, these have the same denominator. Remember, if you have the same denominator before, we just added the top parts. Well, here we're going to subtract the top parts. So we got 4 minus 1. And 4 minus 1 gives us 3. So 3/5 would be our answer. Here's a mixed number. We got 10 and 8/9 minus 2 and 5/9. Now usually with mixed numbers, it's best to put them in a vertical format. And we'll see why later on, because we'll end up borrowing in some subtraction. So I got 10 and 8/9 minus 2 and 5/9. Well, first thing I do is I subtract the fractions. These have the same denominators. That works out perfect. 8 minus 5 gives us 3/9. And then 10 minus 2 gives us 8. Now this reduces. 3/9, top and bottom both lose by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So our answer would be 8 1/3. Well, let's take a look at one with different denominators. So we got 7/12 minus 1/9. Well, we have to get the same denominator. So we'll find our LCD again. So we got 12 and 9. 12 is 2 times 2 times 3. And 9 is 3 times 3. Now again, we start with each prime. We'll start with the first prime, 2. We're looking for the greatest number of 2's on any single line. There's 2 of them here, none of them here. So the greatest number of 2's on any single line is 2. Then I go to the 3. I'm looking for the greatest number of 3's on any single line. There's 1 here, there's 2 here. So the greatest number of 3's on each single line is 2 of them. Well, that's 4 times 9, which is 36. So that's going to be our new denominator. Well, you look at your old denominator and you ask, what did you multiply by to get the new one? Here we had 12. We multiplied that by 3, so we have to multiply the top part by 3. Here we multiply the bottom part by 4, so we have to multiply the top part by 4. So that gives us 21 over 36 minus 4 over 36. And again, if we're subtracting fractions, we subtract top parts. So we got 21 minus 4 over 36. Well, 21 minus 4 gives us 17 over 36. 17 is prime, so I don't think that breaks down any. But we would simplify our fraction if we could. You always do that in math, no matter where. If you can simplify or reduce it, then do that. Let me save that page. And let's look at the next one. So we got 8 and 3/10. And I'm going to put this in vertical format because it really does work out best. Minus 2 and 1/15. Now we're going to subtract these. Well, we first have to figure out what our LCD is. So I go work with 10 and 15. 10 is 2 times 5. 15 is 3 times 5. Our LCD, we're looking for the greatest number of 2's in any single line. There's 1 here, none here, so 1. Then go to the next prime, 3. I'm looking for the greatest number of 3's in any single line. None here, 1 here, so it'll be 1. Then I go to the 5. I'm looking for the greatest number of 5's in any single line. 1 here, so the greatest number of 5's is 1. 2 times 3 is 6, times 5 is 30. So we're going to rewrite both of these with that new denominator. Now you have to look at your old denominator and ask what did you multiply it by to get the new one. This one was 10. I multiplied it by 3 to get the new denominator. So I have to multiply the top part by 3. 3 times 3 is 9. Here I multiplied the bottom part by 2 to get the new denominator, so I have to multiply the top part by 2. So now they have the same denominator, so I subtract the fractions. 9/30 minus 2/30 gives us 7/30. 8 minus 2 gives us 6. So that'd be our answer. Let's take a look at this one. We got 10 minus 2/3. Now, they're kind of implying they want you to do this a little bit different than I'm going to show you in the book. But I always tell people, if you're going to subtract fractions, if you're going to add fractions, they both should be fractions. So you can always create a fraction by putting the number over 1, like that. So I can put 10 over 1. And now they're both fractions. Well, they don't have the same denominator, so let's find that. Well, we got 1 and 3. Now 1 is not even prime. It never comes into play. And we got 3. Our LCD is the greatest number of times each prime appears in a single line. 3 appears once here, none here, so our LCD would be 3. So I'm going to rewrite each of these fractions with that new denominator. Now our second fraction already had the 3, so we leave it alone. Our first one, we multiply the bottom part by 3, so we have to multiply the top part by 3. 10 times 3 gives us 30. Well, they have the same denominators, so subtract top parts. 30 minus 2 gives me 28 over 3. Now this is an improper fraction form, so let's change it. Remember, we do an old style division. 3 goes in 28 7 times. 7 times 3... Okay, let me try that again. Okay, that goes in there 9 times. 3 times 9 is 27 with a remainder of 1. So this becomes 9 and 1/3 as our answer. This particular way, some books will actually express this. Instead of working with mixed numbers, you can just change them all to fraction form, specifically improper fraction, and work with them in that form. Let's take a look at this one. And I'm going to show this one two different ways. And then let you decide which way you want to go with it. So we got 5 1/5 minus 2 4/5. Okay, they have the same denominators, so that's good. But notice, if I were to subtract fractions at this point, 1/5 minus 4/5, I can't do that. So what I'm going to do is I'm going to borrow one, which means try it again. I'll borrow one, so this becomes 4 plus 1 and plus 1/5. And down here is 2 4/5. Now when you borrow one, what it does is this is the same as 5 over 5 plus 1/5. I'm going to talk about the shortcut here shortly, which then would give us 4 6/5 minus 2 4/5. The shortcut is if you borrow one, this number right here, you reduce it by 1. So 5 goes to 4. And then you take whatever your denominator is, see how this is 5, and you add it to the top part. So 5 plus 1 gives us 6. And then the denominator stays 5. So again, this number you reduce by 1, so it becomes 4. And then you take the denominator here and add it to the top. 5 plus 1 gives us 6. So we got 6/5. Now I can subtract these. 6/5 minus 4/5 gives us 2/5. And 4 minus 2 gives us 2. Okay, now let's look at another way of doing that. We got 5 1/5 minus 2 4/5. What we can do is we can change these to improper fraction form. And how you do that is for like 5 1/5 here, you take the number that's out in front of 5 and you multiply it times the denominator. 5 times 5 is 25, and you add the number on top, which is 1. So that'd give us 26. So this would be 26, and then your denominator stays 5. So again, I took the number out in front, multiplied by the denominator. 5 times 5 is 5 times 5 is 25, and I add a number on top. 25 plus 1 is 26. Now our second one here. 2 times 5 is 10, and then you add to 4. That gives us 14. 2 times 5 is 10, add to 4, 14. Now at this point, they have the same denominator. I'll subtract them. 26 minus 14 gives us 12, I believe. 12/5. And we want to change that to a mixed number form. So I do the old style division. 5 goes into that 2 times, 10, 2. So this gives us 2 and 2/5. Mixed numbers are just kind of not very nice to work with in the first place. So I'm going to show this first method because I like it best. Because sometimes your numbers become really huge when you change them to improper fraction form in order to subtract them. I'll probably do one more of these just so you see the flow, but I like the first method best. So let's save that page. And let's look at the next problem. So we got 9 5/18 minus 1 3/4. Okay, well we got a problem here. They don't have the same denominator, do they? So let's get the common denominator first. 18. That's 2 times 3 times 3. And 4 is 2 times 2. So our least common denominator. We start with the first prime, 2. We're looking for the greatest number of 2's in a single line. There's 1 here, there's 2 here. So I'm going to have 2. Then I go to my 3. I'm looking for the greatest number of 3's in a single line. There's 2 here, none here. So it'll be 2 of them. 2 times 2 is 4, times 9 gives us 36. So we're going to rewrite each one of these with the new denominator. Now in the first one here, I multiplied the bottom part by 2, so I have to multiply the top part by 2. So 5 times 2 is 10. Now here I multiplied the bottom part by 9, so I have to multiply the top part by 9. 3 times 9 is 27. Well, we've got a problem here. Obviously I can't subtract 27 from 10, so I'm going to need to borrow. Now I'm going to use my shortcut here. I reduce this by 1. Then I take my denominator and add it to the top part. 36 plus 10 gives us 46. And denominator stays the same. Again, I reduce this by 1, so 9 goes to 8. And then I take this 36 and add it to the 10, and that gives us a 46. Now the y is in the last problem I showed the y, but that's the shortcut for it. Well, now I can subtract 46 minus 27. I'm not sure what it is, but I can subtract it. I think it's 19. So it gives us 19, 36, and 8 minus 1 is 7. Now that doesn't reduce. This one would become so hideous with improper fraction form that mixed numbers really do come out nicer, I think. And actually, I won't even show it because the numbers will be so huge that they're not worth showing. Now let's take a look at this one. So we got 10 1/3 minus 2 5/9. Okay, we first have to find our least common denominator. So we got 3 and 9. 3 is prime, so that's fine. 9 is 3 times 3. So we'll take each prime. Our first one is 3. Now I'm looking for the greatest number of 3's on a single line. There's 1 here, there's 2 here. So the greatest number of 3's on a single line is 2 of them. Well, 3 times 3 is 9. So I'm going to rewrite each one of these with the new denominator. Now this one already has a 9, so we leave it alone. This one, I multiplied the bottom part by 3 to get the new denominator, so I have to multiply the top part by 3. So it becomes 3 9ths. Well, obviously I can't subtract 5 from 3, so I need to borrow. It means this goes down by 1, so that's 9. And then you add the denominator to the top part. 9 plus 3 is 12, so that becomes 12 9ths. Minus 2 and 5 9ths. Well, 12 minus 5 gives us 7, so we got 7 9ths, and 9 minus 2 gives us 7. So our answer is 7 and 7 9ths. Well, let's take a look at multiplication. It's a lot easier. Addition and subtraction, kind of the challenging ones. So, scroll down. And we got 5 thirds times 12 tenths. And this is multiplying fractions. Now our first step is to simplify. And what we mean by that is if you can divide a number on top, so number on top of any fraction, and a number on the bottom not that I can spell bottom, boodum. Okay, let's try it again. And a number on the bottom of any fraction. They don't have to be the same fraction. So if you can divide a number on top of any fraction, a number on bottom of any fraction by a number, do so. Well, let's see how that works. In this problem here, we have a number on the bottom here and a number on top, 3 and 12. Well, those are both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So we're left with 5 over 1 times 4 over 10. All the guideline is one's on top, one's on the bottom. Well, here I got 4 and 10. Those are both divisible by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So we've got 5 over 1 times 2 over 5. And we have 5 here, 5 here. These are both divisible by 5. 5 divided by 5 is 1. 5 divided by 5 is 1 here. And this is what we're left with. So our second step is to multiply the top, multiply the tops, and multiply the bottoms. Well, 1 times 2 is 2, and 1 times 1 is 1. And then step 3 is simplify, if necessary. Well, 2 divided by 1 gives us 2. So that would be our answer. Now you're going to find that there's not a whole lot of simplification necessary here if you've done a good job right up front at step 1. And that's where you should do it. You shouldn't wait till the very end, because sometimes your numbers can become real huge. Attack them while they're small. Well, let's take a look at another one of them. This one we got 20 over 5 times 10 over 12. Now it doesn't matter which numbers you pick, just as long as a number on top and a number on the bottom are divisible by the same number. They can be in the same fraction or in different fractions. Here's a 5 and 10. Those are both divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So I got 20 over 1 times 2 over 12. Well, 2 and 12 are both divisible by 2. So 2 divided by 2 is 1. 12 divided by 2 is 6. So I got 20 over 1 times 1 over 6. Numbers on top, numbers on the bottom. That's the only guideline. Here's a 20 and here's a 6. They're both divisible by 2. 6 divided by 2 is 3. 20 divided by 2 is 10. So we got 10 over 1 times 1 over 3. Nothing else to simplify, so I'll multiply the top parts together. 10 times 1 is 10, and the bottom parts. 1 times 3 is 3. Now this one we can actually change the mixed number form. It depends on what the problem is looking for. If they want you to leave it in this form, then this would be your answer. If they want it in mixed number form, then you go further. Remember, we take our number on top, divide by number on the bottom. That'd be 3, 9, 1. So this would be 3 and 1/3 for our answer. Number on top, so it goes out here. The remainder is what goes on top. And then the denominator stays the same. So our answer would be 3 and 1/3. Let's save this. And we'll look at another multiplication. Here we got 4/15 times 9. Well, remember what I said earlier. I said if we're going to add or subtract fractions, they both should be fractions. If we're going to multiply fractions, then they both should be fractions. So same idea. So we're going to take the 9 and we're going to put it over 1. Okay, now our only guideline is one's on top, one's on the bottom. Here's a 9 and 15. They're both divisible by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. So we've got 4/5 times 3 over 1. Now there's nothing else to simplify here, so I can go ahead and multiply everything together. 4 times 3 is 12, and 5 times 1 is 5. Now again, I'm going to change that to a mixed number. So take my number on top, divide by number on the bottom. Because it's improper fraction, that's where the number on top is larger. 5 goes into 12 2 times. 2 times 5 is 10, and 2. So this would be 2 and 2/5 as our answer. Again, whatever number's on top here goes out in front. Whatever your remainder is goes right there. And what you're dividing by goes right here. Well, let's take a look at another one. So we got 8/24 times 6/10 times 20 over 3. So we're multiplying 3 fractions together. Well, that rule, one's on top, one's on the bottom, it holds true no matter how many fractions you have. They don't have to be next to each other. Here I got 20 and here I got 24. Those both divisible by 4. 20 divided by 4 is 5. 24 divided by 4 is 6. So we get 8/6 times 6 over 10 times 5 over 3. Only rule is one's on top, one's on the bottom. They can be in the same fraction or not. Well, here's 6 and here's 6. Those are both divisible by 6. 6 divided by 6 is 1. 6 divided by 6 is 1. So we got 8 over 1 times 1 over 10 times 5 over 3. Well, here's a 10, here's a 5. They're both divisible by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So this becomes 8 over 1 times 1 over 2 times 1 over 3. Still can simplify it. 2 and 8, these are both divisible by 2. One's on top, one's on the bottom. That's only guideline. 2 divided by 2 is 1. 8 divided by 2 is 4. So we got 4 over 1 times 1 over 1 times 1 over 3. And actually nothing else simplifies now. So multiply the top parts together. 4 times 1 is 4 times another 1 is 4. 1 times 1 times 3 is 3. Again, compare that against multiplying 8 times 6 times 20. I have no clue what that'd even be, and that'd be horrible to try to simplify. So simplify before you multiply them together. Now this one becomes 1 and 1/3, changing the mixed number form. Again, we do this right here. Divide number on top by number on the bottom. This is what goes out in front. Our remainder. So it goes up on top. And what we're dividing by goes right there. Well, this next one introduces something we've already talked about, but it's necessary for multiplication of mixed numbers. So we got 4 2/5. And it says change these mixed numbers into improper fraction form. Now again, what we're going to do, let me write out all the steps on this. We're going to take the number that's out in front, multiply it times what the denominator. So we're going to take 4 times 5, and then we'll add the number on top, which is 2. And the denominator stays as is. So again, I take the number out in front times the old denominator, and then I add the number up on top, like that. And then the denominator stays as is. Well, 4 times 5 is 20, plus 2 is 22. So it'll be 22/5. Again, most people don't show that step. You just take 4 times 5 is 20, add 2, and that gives you your 22. The denominator stays as is. Well, where does that come in handy at? Well, for multiplying mixed numbers together, it doesn't work well unless we put it in the right format. So I got 7 1/2 times 5 1/3. You cannot multiply 7 times 5 1/2 times 1/3. So we have to change these to mixed number form. Well, 7 times 2 is 14. Add to 1, that gives us 15. So that's 15 halves. And here we got 5 times 3, which is 15. Add to 1 gives us 16. Like that. Again, 7 times 2 is 14, plus 1 is 15. Denominator stays the same. 5 times 3 is 15, plus 1 is 16. Now once we have it in this form, then we proceed like we did before. Again, if you can divide a number on top and a number on the bottom by the same number, do so. Those are both divided by 2. 2 divided by 2 is 1. 16 divided by 2 is 8. So that gives us 15 over 1 times 8 over 3. Well, a little bit more simplifying. 15 and 3 are both divided by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. So we end up with 5 over 1 times 8 over 1. Now nothing else to simplify, so I can multiply the top parts together. 5 times 8 is 40. And the bottom parts, 1 times 1 is 1, which gives us just 40. That one was interesting. I would never have guessed that. But that'd be our answer. Now let's talk about division. We got 8/3 divided by 4/6. Now division is pretty straightforward. I'm getting my book out here. We're getting ready to do Celsius and Fahrenheit, and I don't remember the formula. Just kind of looking ahead. There it is. Okay. To divide fractions. We're going to rewrite as multiplication by flipping the second fraction. We're talking about the fraction that follows a division symbol. And then multiply. So nothing exciting there. So the 8/3 remains as is. We rewrite it as multiplication by flipping the second fraction. So this becomes 6/4. Now that's called a reciprocal. Now at this point, we just do what we've been doing. Well, simplify. 8 and 4 are both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So we got 2/3 times 6/1. 3 and 6 both divisible by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. And that gives us 2/1 times 2/1. Nothing else to simplify, so multiply the top parts together. 2 times 2 is 4. Bottom parts, 1 times 1 is 1. And 4 divided by 1 is 4. Yet another one that came out really nice. That's interesting. But again, we rewrite as multiplication by flipping the second fraction, taking the reciprocal of it. Reciprocal, that's a fancy word for saying flipping the fraction. In this case. Now let's take a look at this one. We got 14/5 divided by 21. Well, if we're going to divide fractions, it's helpful if they're both fractions. So I want to put 21/1. And we never divide. We immediately rewrite as multiplication by flipping the second fraction. So that becomes 1/21. Again, taking the reciprocal of it. Now let me write that word down in case you're wondering how it's spelled. Reciprocal. Now we simplify. If a number on top and a number on the bottom both divisible by the same number, divide them. 14 and 21 both divisible by 7. 21 divided by 7 is 3. 14 divided by 7 is 2. So we got 2/5 times 1/3. Well, can't simplify anymore, so multiply the top parts together. 2 times 1 is 2, and the bottom parts, 5 times 3 is 15. So our answer is 2/15. Well, let's take a look at dividing mixed numbers. Just like multiplication, we can't work with these very well in this form. We're going to convert them to improper fraction form first. Well, 10 times 3 is 30, plus 2 gives us 32. Again, take the number out in front times the number downstairs. 10 times 3 is 30, and add the number on top. 30 plus 2 is 32, and denominator stays the same. On this one, 5 times 2 is 10, add the number on top. 5 plus 2 is 10, plus 1 is 11. So that gives 11/2. Well, we never work with division. We immediately rewrite as multiplication by flipping the second fraction. So that becomes 2/11. Again, flipping the second fraction is a reciprocal. Oh, wow. Nothing simplifies. So we multiply the top parts together. 32 times 2 is 64. And the bottom parts, 3 times 11 is 33. Well, now we'll do our division. 33 goes in 64 one time. 1 times 33 is 33. Subtract that. And we get 31. So this becomes 1 and 31 over 33. Again, number on top is what goes here. Your remainder, whatever it is up on top. And then what you're dividing by is your denominator. So that'd be your answer. Okay. And here's the ones where I had to look up the formula. If I had any kind of memory, I'd memorize these, but in fact, I don't use them very often. I don't need to memorize them. Okay, so this says convert to fall into Fahrenheit, leaving fraction form. And I'm looking in the book, see what the formula is. And they'll probably change additions, but this is the very end of the Unit 2, and I'm looking at page 64. It says to convert Celsius to Fahrenheit. You take your Celsius, and they actually have the little symbol there. They put it out in front. Not that it matters. They put it right there. And then you multiply that times 9/5. And then you add 32. And that's going to give you your Fahrenheit. Well, we've already talked about this. If you have multiplication of fractions, they both should be fractions. So put 30 over 1, and I'll drop that degree. I know it needs to go on there at the end. Times 9/5 plus 32. Again, if you're multiplying fractions, if you can divide a number on top and a number on the bottom by the same number, do so. 5 and 30 both divisible by 5. 5 divided by 5 is 1. 30 divided by 5 is 6. Now, nothing else to simplify there, so I go ahead and multiply them together. 6 times 9 gives us 54. 1 times 1 is 1, plus 32. 54 over 1 is 54, plus 32 equals F. And add those together, and that gives us 86 degrees for Fahrenheit. So again, that one worked out really nice. Make sure I'm looking at the right formula. Convert Celsius to Fahrenheit times 9/5 plus 32. Yep, that's our answer. And our last problem. We got 60 degrees Fahrenheit. And the formula here says to convert this to Celsius, we take our 60 degrees minus 32 times 5/9, and that gives us our Celsius. Well, 60 minus 2, or 60 minus 32, sorry. We do what's inside parentheses first. Gives us, what, 28? Yeah, 28. Times 5/9 equals C. Now again, we want to put both of these in fraction form. If I multiply fractions, they both should be fractions. Now this one doesn't reduce at all, so I just go ahead and multiply the top parts together. 28 times 5 gives us 140 over 9. So that's our answer in Celsius. If they don't want it in that form, we convert it to a mixed number. Let's see, 9 goes into 14 one time, then that'd be 50. Drawing a blank. 5, I think. Okay, 45. And then 5 there. So this would become Celsius would be equal to 15 and 5/9. Again, number on top goes right there. Your remainder right there, and then what you're dividing by is right there. And I didn't put the degrees on there. Something was missing, so a little degree symbol. But anyway, I'm not sure which answer they would want in your particular field. You know, if you go to nursing, they may actually like this one better, 15 and 5/9. You probably round it to 16 if I had to guess. But anyway, that's the end of the unit.